My name is Jonthan Kyle. I lead global business development and go-to-market strategy for digital twins at AWS. I'll be joined a little bit later by Colin Yao, CTO of Holo One, and we're going to be discussing today spanning time and space with mixed reality digital twins. Now, what do I mean by that? What do I mean by spanning time and space? Well, spanning time in the sense of leveraging the predictive capabilities of digital twins, one of their biggest value propositions. And spanning space with the use of mixed reality, connecting the physical and the virtual world together. Now, when we talk about digital twins with customers, it always generates a lot of interest. They all want to use, to develop, to build digital twins. Then they ask, what's a digital twin? So we usually have to back up and do some level setting and describe what we mean. We're not saying you have to use this definition, but it definitely helps the conversation when we're on the same page. So we start saying, it's a living digital representation of a physical system, dynamically updated to mimic the structure. But it has to drive a business outcome. And I think that last piece is the most important. In my experience, the last few years, with all this excitement, people have kind of forgotten that last little piece. And then they get to the end of a POC, and they want to put it in operations, and they don't really remember why they even wanted to start down this journey to begin with. These four components, the physical system, it could be an industrial asset, it could be an ecological system, it could be even the human body, externally as an avatar tracking motion, it could be internally the human body using wearable technology and sensors and updating a model. The key is it's something tangible. The second is a digital twin, the virtual representation, and this is a model, and by model I mean a response model. I give it an input and it provides me an output. It could be a first principle physics-based model, could be a computer science data model, it's some type of model. And the third piece is this connectivity between the two worlds. And again, the business outcome, at AWS, at Amazon, we're very customer-centric. This is where we work backwards from. Before we start talking about what's the technology, what are we going to use, what's the business outcome that you're trying to achieve? And then we can work backwards from there and figuring out what are other similar use cases that we can leverage, and what's the tech stack look like to make that digital twin. Now, one thing that I found interesting is digital twin is not a new concept. It's been around since 2002. Dr. Greaves came up with it. At the time, it was called cyber-physical modeling and systems. The term was coined in 2010. So in terms of tech, this is pretty old. Why haven't we seen digital twins widely deployed in a fleet, for instance? You see a lot of POCs, a big graveyard of them, but not much else. And I think it's because digital twin has been successful from a marketing perspective. In the past, let's say 6 years, it's gained a lot of traction. I think we're coming to the end of this hype cycle, and you're seeing the convergence of 4 real mega trends that will accelerate this even further. The first being just the cost of sensors alone. You go back to 2010, right, and IoT sensors. I had customers saying, this sounds great, but it's cost prohibitive if I want to sensorize everything. The cost of sensors has dropped 50% in just the last 10 years. So what was once cost prohibitive is now a commodity. So if you think about it, that's inevitable. More and more sensors collecting more and more data. That's great. The second is the connectivity, transmission of that data. And if you look at wireless technology as a proxy, in 2010, 3G was the de facto wireless standard. Okay, 100 kilobits per second, pretty good. Then late 2010s, we go to 4G, 100 megabits per second. Now we're at 5G, 10 gigabits per second. That's a 1,000-fold increase in just 10 years. So now I can transmit almost any data that I want in almost real time. And then not just looking at speed, but availability. Now we have multiple satellite constellations spanning the globe that will transmit data at roughly the same speed no matter where you are. So you can be an oil and gas company with an offshore drilling platform and still upload and harvest all that data. So those two major megatrends are about collecting the data, but data is not information, and information is not knowledge. The real value of the digital twin is converting all that data into actionable knowledge. And that's where the third megatrend of modeling, the digital twin aspect, has really seen an explosion in terms of machine learning models, statistical modeling, and that's being driven a lot kind of with the computer science side, but also with the fourth megatrend of at-scale computing. Now, a single developer can spool up tens of thousands of GPUs to train models and update them in real time, which which was very expensive to do not that long ago. Even with this definition, though, we see use cases that our customers are asking for digital twin and where it causes a lot of confusion that doesn't quite fit that definition that I gave previously. So we came up with this leveling framework similar to what they use in the autonomous vehicle space with L0 through L5, L0 being a fully manual vehicle, L1's like cruise control, all the way to L5 where it's fully autonomous. So that definition I gave before would be what we would call an L4 living digital twin. And not saying L4 is better than L3 or that you have to go in that direction. The point is, again, demystifying the term. What are you really trying to achieve here? And I'll go quickly through all of these. L1 is a descriptive digital twin. This is just a virtual visual representation of what you're working on. And this has been around for a while now. Things like CAD geometry, BIM models, any type of simulation, CAE tools. And the real value here is instead of moving atoms in the real world, you're moving bits in a virtual world. You can do things like virtual prototyping, go to market faster with product design, things like that. So we would call that an L1, descriptive. And L2 is informative. Now you're integrating IoT sensor data. You're contextualizing that information. You're not doing any predictions with it, but you can do a single pane of glass, a dashboard, or any 3D contextual environment to help you explore and visualize a space. We would call that an L2 digital twin. L3 and L4 is when we start learning the behavior of the system. So L2 informative, you're learning about the state of the system. L1, you're learning about the structure of the system. But L3 and L4 is the behavior of the system. And this is where modeling comes in, being able to predict unmeasured quantities into the future. So this is part of that spanning the time aspect of the digital twin. The difference between the L3 and L4 is L3, I have this implicit assumption that future behavior will be the same as past behavior. This is a core principle of a lot of machine learning techniques. You have a training set, you're training a model, and you're hoping that in the real world, you're not going to deviate that far from that training set. But we do know that doesn't always happen. And in fact, a lot of these corner cases of things that have never happened before, and I've never trained my model on it, but I still want to be able to predict things, that's where the L4 living digital twin is. It's actually using the data coming in to update the model itself autonomously. It's updating the model parameters to give you a better model to mimic what's actually happening with my asset. So for instance, if I have a gas turbo pump and it's wearing away after a lot of use, or a heat exchanger that's following up after use, or a battery in an EV vehicle that's degrading over time, you need to have a capability of updating that model. So the business value for L3 and L4 is being able to do things like predictive maintenance, sustainment, going from schedule-based maintenance to more like condition-based maintenance, calculating things like remaining useful life of assets. I know this is a little bit of an eye chart, but the key I just want you all to take away is AWS has many different services that cover this entire continuum. But you can see why we like to work backwards. We don't want customers coming and saying, just show us everything that you can do, because it's just going to be spaghetti at a wall. We really need to work backwards from what a digital twin is, what level we think will be best for your organization and your company, and then we can work backwards and see, okay, what services do we need to stitch together to provide that solution. But two, I do want to highlight real quick, AWS IoT TwinMaker, that would fit in an L2 informative digital twin that was released last year to the public. It allows you to connect disparate data sources and contextualize them in a dashboard or 3D environment, but it doesn't do any predictive capabilities yet, so that's why we put it in L2. L3, Lookout for Vision, is another service I'd like to highlight. So that relies on computer vision, taking that feed in and doing things like anomaly detection, anything that looks off from what it's seen previously. And with that, I'd like to invite Colin up, who will give a brief overview of digital twins on their mixed reality platform. Thank you.
Thanks for that introduction, Jonathan. My name's Colin. I'm the CTO at Sphere. Before I dig deeper into how Sphere supports digital twins and live maintenance, I'll take a bit of a step back and discuss what Sphere does as a whole. Now, Sphere is a off-the-shelf turnkey solution that unlocks a lot of different use cases in enterprise XR, all based around productivity and communication. Collaboration really sits at the core as a fundamental for the entire solution. That's real-time, it's multiplayer, it's networked, and layered on top of that are all these use cases that it unlocks. Sell is directed at sales pre-visualization, being able to give pitches and demos around digital, life-sized, and interactive 3D content. Train, which will become a bit more of the focus with Lookout for Vision and digital twins, provides step-by-step workflow guidance, standard operating procedures for users to help them, whether it's a routine maintenance or perhaps training a new employee on the job. Expert, this is a very classical remote assistance use case for XR, streaming that live headset audio and video to someone off-site to get that expertise. And lastly, build, being able to have a one-to-one life-size overlay, walk through it, whether that's a new factory layout or a new construction build site. And all of this runs on any device, any deployment configuration, you name it. Now, specifically for Train and for workflow guidance, XR-powered instructions offer a lot already for existing customers, whether it's paperless recording, having everything digitized. This is a big step already for a lot of customers. And what we try and answer with this is have a record of what was performed and guide the user through the various steps. For some companies, this is still not enough. And this is where Lookout for Vision and Sphere have tried to take this a bit further, answer not only what was the work that was performed in the context of a procedure, but also was that work performed correctly? And can we give that feedback to the users on site in real time? And it's really about moving from a model that's based around retroactive review, maybe in a back office after the work is done, to having that live, on-demand, on-site feedback. So to make this a little more tangible, these are some of the steps that are involved in the setup of a precision measurement machine. In manufacturing, you're producing very specific parts, very detailed specifications. They need to be airtight to the millimeter. And it's a culmination of a lot of small steps that need to be done very carefully and controlled to make sure that this last quality assurance piece is done correctly. So whether that's having the correct number of spacer plates in the measurement machine, making sure the pins are in the right slot, or the component is mounted correctly, in each of these small steps, Lookout for Vision can help tell us, is it being done correctly? And avoid the case where it's not done correctly and the measurement machine crashes into the slide and that machine is down. Now, to take a step back, how does this fit in the context of a digital twin? Sphere integrates with upstream tools for IoT and for digital twins, AWS SiteWise, AWS TwinMaker, and this is where all the sensors are monitored, rules and alerts are configured for the different actions that might occur for a physical asset. And whether it's for predictive maintenance or an emergency action that needs to take place, Sphere responds to triggers from these systems. The users get a notification for executing a specific step-by-step guidance that's for a specific problem that's been identified and mapped in that digital twin. And along the way, with each step, there are all these off-ramps to extend and enhance that experience. One, for example, is live remote assistance. It's being able to call out to an expert directly within Sphere who sees what you see from the headset, also has access and history to every step that's been performed to date. And the other is what we call supervised workflow guidance. And this is where Lookout for Vision really comes into play. Users can capture on their headsets or phones or tablets the existing state, whether that's a photo or video, send that to Lookout for Vision. And Lookout for Vision can tell us, is this a pass or fail condition? Is there an anomaly? If there is an anomaly, where is it occurring? And being able to provide all this contextual information back to the user in real time is incredibly valuable for reducing downtime and error rates. Ultimately, at the end of that process, everything's wrapped up. All the metrics around execution time, rework, and the answers that were given are sent back to those upstream systems. So you have a single source of truth for not only the sensor data, the actions that have been alerted, but also the response to those actions. Now, I highlighted before that real-time collaboration underpins all these different use cases. This is certainly applicable for a single user on site. It's equally as seamless to do this with 3 people in a team who need to execute that workflow as a group, or to perhaps train new teams on this particular procedure. And this multi-user collaboration is underpinned by a lot of great things that we built into Sphere. Having a realistic and lifelike avatar system that behaves and captures the nuance of a user on site. Integrations into Microsoft Teams, Zoom, Chime, Slack soon to come, and also live audio translation, captioning, and dictation back in a native language powered by tools from AWS like Translate, Transcribe, and Poly, all with the ultimate goal of not only bridging that physical distance between cross-geographic teams and remote work, but also that psychological distance that can be experienced, the engagement kind of problem. I'm sure we've all felt, kind of the, let's say, call fatigue that comes from back-to-back-to-back video calls. Now, I want to discuss what this means in a real world for a real customer. One of our customers, Micron Technology, is using our workflow guidance tool to help guide their workers in their fabs all around the world. And using Sphere, using our tool, they've saved over 3,000 hours of tool downtime in the past year, and 1% to 2% increase in machine availability. And for them, this ROI is measured in the millions of dollars, right? And I think this has been discussed by everyone else, that the future is now, XR is here. I really want to emphasize that Micron, along with our other customers, have really deployed this productively. There's tangible and measurable ROI for them. It's less of a conversation now for them of experimentation and exploration, and it's really focused on giving them a competitive edge and ultimately operational excellence for their teams. So I want to encourage you to connect and reach out if you're interested to learn more. Otherwise, I'd like to thank you and wish you a good rest of the few days in Miami, and please enjoy the conference. Thanks, everyone.